Good day, Algebra. Will warning for you. We are starting off our final unit of the year with the big one. It's PO61, and there are 3 parts to it. Our last unit is all going to be about square roots and how square roots interact with each other. We're going to start by kind of going back to when we first evaluated roots, estimated roots. You've done that before. Then we're going to get into simplifying roots, which is going to be new. Okay. From there, we launch into addition and subtraction with roots, multiplication and division with roots, and finally solving for a variable when you have a square root in an equation. But going back to what you may be familiar with, Damien, turn around, please. Starting with evaluating and estimating, Alex, yes. When we talk about evaluating versus estimating versus simplifying, those are 3 different things. Okay. When we evaluate something, it means we can come up with a recognizable value, right? A whole number, an integer, something that we can look at and say, yes, I know how much that is. So when we evaluate a radical, notice we're dealing with perfect squares, right? This is what you start with. What is the square root of 36? Joey? 6. Okay. And because we are not in the context of parabolas, we don't need that other value, right? That positive or negative 6. 6 is just fine. Okay. Evaluate the root of 121. Kylie. 11. Right? Okay. Good. Fantastic. When we move to estimating now, right? Estimating is when we kind of round. We kind of make a guess. It's not an exact value, right? But it's close. So in CO2, way back at the beginning of the year, we talked about how to estimate a square root. Who can give me an estimation for the root of 19? Max?
4.5.
And how did you come up with that?
Well, 16 is like really close and it's 4, so I just rounded up a little bit.
Sure. What we talked about was using those perfect squares on either side of it. And the fact that 19 is about halfway between 16 and 25, a little bit closer to 16. Okay. Knowing that the root of 16 is 4 and root 25 is 5, we can estimate this to be about, in class, we would say 4.3, 4.4, something like that. Okay, 4.5 is a fine estimation too. It's not exact, right? It's approximate. Yeah, well. Yes. Okay. How about the root of 200? Who can give me an estimation for the root of 200? Elliot.
It's like 14.
About 14, right? What is 14 squared? 196. 200 is a little bit more than that. So 14.2, right? 14.1, something like that. Okay. Yes. CO2. Yeah. Like the second week of school. It's been a long time. How about the root of 44? Who can give me an estimation for that?
Like 6.6 or something.
6.6, root 44 is between root 49, which is 7, root 36, which is 6, closer to 49. So yeah, 6.6, 6.7, somewhere around there. Okay? When we talk about simplifying, though, we are looking for an exact value, but it's not necessarily going to be recognizable. Notice that root of 45, not a perfect square. Root of 20, not a perfect square. Root of 700, etc. But we're not interested in just getting a decimal approximation here, which is why some of the comments when you first open is like, oh, we can use our calculator. No, your calculator is not going to do this for you. Hold on, I'll leave you on that cliffhanger while I answer the phone. Yellow. Oh, that's okay. Hi. I did. It took me a little bit to remember what that was called, but I got it because it rhymes with esophagus. Yeah. So, all right. Well, have a good day. Bye.
Asparagus.
Sarcophagus. Okay. So anyway, your calculator is not going to be able to do this for you because we are going to be looking to simplify a non-perfect square. And when you put a non-perfect square in your calculator, what do you get?
A decimal.
Okay. Your calculators can't do this part for you. So here's the process. What we're looking for when we want to simplify a radical such as root 45 is we're looking for factors of 45. Okay. Factor the 45. 9 and 5 is one factor pair. What's another factor?
3 and 15.
3 and 15 is another factor pair.
1 and 45.
Right? 1 and 45 is also a factor pair. However, for this objective, we will never use the 1 and the 9. Okay? Because what we're looking for is we're looking for a factor pair that contains a perfect square. So by show of hands, our two that we have up there, 9 and 5 and 3 and 15, which one of those contains a factor that is also a perfect square, Kylie? 9 and 5. Okay? And the reason why we want this is because in math, there's a property that says if we have the root of 45, oh, I have to calibrate. Hold on, I'm going to leave you hanging with that property while I calibrate the board.
What a cliffhanger.
There's a property in math that says if we have the root of, say, 45, we can split that up into factors as long as we keep the root. So the root of 45 is equal to the root of 9 times the root of 5. Okay? Because 9 times 5 equals 45, the root of 9 times the root of 5 will equal the root of 45. Now, why do you suppose we wanted that perfect square factor? What can we do now that would simplify this expression? Alex?
I don't know, but 5 isn't a perfect square.
5 is not. We only want 1. Only one of them needs to be perfect. What's that?
Why can't you use the other?
Because in 3 and 15, neither of those is a perfect square.
Oh.
Right?
What if there's multiple perfect squares? Like,
If you get multiple perfect squares, like in 700, we'll talk about that.
you can just pick one.
Okay? Talk about that. No, you can't just pick one. We'll talk about that. Why do you suppose we wanted that root 9 though? Lisa?
So that we can like simplify it and 3 and 3.
Yeah. We wanted that perfect square so we can take the root of that value. The root of 9 equals 3. As Alex pointed out, 5 is not a perfect square. We don't care. Our simplified answer is going to be 3 times root 5. Okay? That's our answer. 3 times the root of 5. If you want to put the multiplication symbol in between them, you can. But just like you don't have to put it between a coefficient and a variable, you don't have to put it between the coefficient and a root.
Do it anyway.
It's under.
What's
that? Well, so Christopher brings up, folks, I need to be quiet. Christopher brings up a valid point. Why it's important to be neat in mathematics, which is why my handwriting is always so pristine. You do need to be careful that you don't make that 3, small and write in the crux of that root symbol, because that would be the cubed root of 5. Right? Damien, warning for you. So instead, make sure that you make it, large enough so that it's recognizable as a coefficient, so that it's 3 times root 5. Okay? We don't want to put the 3 after the 5, because if we did that, then it might look like, is that the root of 53? Is it right? So the integer value would come before the root, large enough so we recognize it as a coefficient. Arlene, get your hand up. Yes.
Can you choose one of those and which shows us that no options are a square?
No, none of the factors have a square.
In these examples, I believe all of them have at least one perfect square factor. If you ran into something like the root of 15, where there was no perfect square factor, then you would not be able to simplify that. So just once. Okay?
So you can say no.
Right? So you have to have a perfect square factor to do, and all of these will. Okay? How about the root of 20? Okay, think about those factor pairs of 20. What multiplies to make 20? And then think about which one's going to be advantageous to you because it contains a perfect square. Rowan?
4 and 5.
4 and 5, right? Our two options are either 2 and 10 or 4 and 5. And because 4 and 5 has that perfect square 4, that's to me the one that we want. If we took, root 2 times root 10, what can you do with that? Nothing, right? So we want the root 4 times root 5. Because how can this be simplified? Damien.
The 4 is simplified to 2.
Right, the 4 becomes a 2. Root of 4 is 2. And then the root 5 we can't do anything with. We don't care. 2 root 5 would be our simplified answer. Okay? Lisa.
What if there are two numbers that are perfect squares?
If you end up trying to factor something, or that they're both perfect squares, then what you started with was also a perfect square. Like for example, okay, let's take the root of 36, which up above we already simplified to be 6. What's a factor pair of 36 with a perfect square?
9 and 4.
9 and 4, right? But if we write root 4 times root 9, root 4 is 2. Root 9 is 3. 2 times 3 equals 6, which is what root 36 equals anyway. Right? So if both of your factors are perfect squares, then what you had to start with was a perfect square as well. Okay?
Wait,
Good question. Yeah.
so then, say you had like one like that.
Jack, Vincent, morning, peace with you.
If we had one like that, would we just write, and we won't have to show all the.
Right. If you've got one that's a perfect square, you can evaluate it.
So, okay.
Right? We have evaluation, we have estimation, and now we're focusing on simplifying. Okay? Let's look at 700. Give me some factor pairs of 700.
10 and 70.
Okay? 10 and 70 is a factor pair. Sally?
7 and 100.
7 and 100 is a factor pair. Max?
4 and 175.
4 and 175.
28 and 25.
25 and 28. I'm reordering them so the perfect square comes first, just because that's how you would write it here. So that's why I put it that way. Except for 7 and 100, I put that one smaller number first for some reason. Maybe it's smaller number first. I don't know why. 7, 9, and 5. I'm inconsistent. Anyway, Callie.
2 and 350.
2 and 350. Okay, that's enough to put up there because what are you seeing here? What are you? Yeah, there's multiple things with perfect squares, right? We've got 7 and 100, which that contains the perfect square of 100. We have 4 and 175, and we have 25 and 28. Okay, when you run into that situation, which I believe was Damien's question earlier, what do you think you're going to choose? What do you think you're going to choose? Easiest one, okay? I'll relate it back to a fraction. If I had you simplify the fraction, say 10/20ths, there are multiple ways that you could, or multiple things that you could divide each of those by, right? You could divide by 2, you could divide by 5, you could divide by 10. But if you want to put it in the simplest form, what would you divide 10 and 20 by? 10. Just the largest one, right? So which factor pair are we going to choose here?
7 and 100.
7 and 100. We want that largest perfect square. If you've got multiple options,
Wait,
you want to pick the largest perfect square. Because if you don't, if we were to simplify this by simply dividing each by 2, we have to simplify it again, right? If you go with 4 and 175 or 25 and 28, you have to simplify a second time because you didn't pick the largest perfect square factor. Yeah.
175 is bigger than 100.
But 175 isn't a perfect square, right? You want the largest perfect square factor. Yes, sir.
They put the square root of 363 on twice.
They put? You mean I put?
Yeah.
Oh, my editor will be fired. Thank you. Right?
So you're gonna figure yourself.
No, I'm an editor. I don't think mistakes does. That's my editor does. I don't think what? Wow.
People never make mistakes. He is.
Okay, so we are choosing root 100 and root 7. Root 100 being that largest perfect square. The root of 100 is 10. Root 7, we don't know, we don't care. 10 root 7 would be our final answer. Okay? Let's just say, just for pointing this out, that you didn't think of 7 and 100 and instead you went with root 25 times root 28. Let's just see what happens when we don't pick that largest perfect square. Root 25 is 5. Root 28, we don't know, we don't care. However, what can we do with that root 28?
Simplify
How?
by
by dividing
28
by 3.
1, no.
25.
What are factor pairs of 28? One of them being a perfect square. Arlene. Okay. If you didn't use the largest perfect square, you'd find that you could simplify that other number further. In this case, 4 times 7. This root 5 is still chilling out in front. The root of 4 is?
2.
Root 7, we don't know, we don't care. And what do our two coefficients 5 and 2 equal when we multiply? 10 root 7. Okay?
No matter what.
So you can still get to the final answer if you don't pick the largest perfect square, just like you can still get to 1/2 if you don't divide by 10 right away. But it's much more efficient to pick that largest perfect square and get that simplest form immediately. Yes?
So is a way you can check if the number is a prime?
What do you mean? Oh, yes. Not necessarily. Like if we had root 15 left over, we wouldn't be able to do that. Okay. How you can check if you have a large perfect square, it kind of goes back to your understanding of what perfect squares are. And always looking for, can I divide by 4, by 9, by 16, by 25? How you can check your answer to see if you've done that part right is you can go to your calculator, enter in the root of 700, whatever nasty decimal that value is, then go in and enter 10 times root 7, and those two decimal values will be the same.
Okay.
So you can check your answer in a way that way, but knowing whether or not you got all the way down the simplest form, you kind of have to know your perfect squares and know what else you can divide by. Okay? Other questions? Yes, Alex.
So what do you group the 700 and then what?
To check your answer?
Yeah.
So you'd, in your calculator, take the root of 700, okay? 26.45, yada, 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 okay? Then you take 10 times root 7, and you'll get that same 26.45, etc., etc. And because those decimal values match, then you know you've done it correctly. Okay? Okay? Joey, warning for you. Stop. Elliot.
So like, on 72, I did square root of 9 times square root of 8,
Yeah.
but that gets you the smaller number. So wouldn't that be like the smallest simplifying?
So there's a larger perfect square than 9 that goes into 72.
Yeah, it's 36.
Right. So that's what you want to use. Because in root 9 times root 8, you can simplify that root 8 further.
But it still gives you the same answer.
It gives you the same decimal value, right? Just like 10 divided by 20 and 5 divided by 10 are both 0.5, but 5/10 isn't simplest form. Okay? So that comparing decimals is more just to make sure that you did your math correctly once you find the largest perfect square factor. But you have to recognize, take a look at when you're done. If you did root 9 times root 8, you need to look at that root 8 and say, is there a perfect square factor that goes into 8? 4, so you'd have to simplify it further. So knowing your factor pairs is very important in this concept. Your calculator can't really help you with that part of it.
Found it.
Alex.
On the test, let's say you put 3 over 8, because you did the 9 and 8.
Yeah.
Would it be wrong?
Correct. Yes. It would be wrong.
No.
Just like if I told you to simplify 10/20ths and you put 5/10ths. I mean, did you simplify? Yes, but it's not in simplest form. We are going for simplest form.
Just a simplify.
Simplest form.
It doesn't say 6 or 8.
Thank you, Alex. Lisa.
So, what if there's like,
Already have it.
what if there's like no other thing, no other like, factors, but it's like even and we can't like, it has to be simplified, but
Do you have an example?
I'm confused with myself.
Okay. Okay. Yeah.
What is 72 together?
72. Okay. Look at 72. What are some perfect square factors? We already know that 8 and 9. Oh, I'm so right through a symbol. We already know that 8 and 9 is a perfect square factor. What else? Vince?
36.
36 and 2. What else? 6 and 12. What else? 4 and 18. Okay. We have a couple perfect squares here. The 6 and 12 is the only one that's completely useless because that is no perfect squares there. But 8 and 9, we got 9. 36 and 2. 36, 4 and 18, we got 4. Which one? Not saying that I still want it up there, but it's not going to help us further. Which factor pair are we going to use here? Ellen. 36 and 2, because that is the largest perfect square factor. Okay, so you'd start with root 36 times root 2, right? Root 36 becomes 6, and we don't know what root 2 is, don't care. 6 root 2 would be our simplified answer.
You would do 9 and 8.
Yep.
That's what I did.
So if you use 9 and 8, then you run into that situation again, where root 9 equals 3, but then you can still simplify that root 8, right? Because what's a perfect square factor that goes into 8? 4. So then it'd be 3 times root 4 times root 2. The root 4 becomes root of 4 is 2.
Oh, yeah.
So then you have 3 times 2 times root 2, and you can combine that to be 6 root 2. So you still get there, but it just takes longer. That's all.
Yeah.
Ellen.
So the number in the root doesn't always have to be prime, or does it have to?
Doesn't always have to be prime. It won't always be prime. Oftentimes is, but not always. Elliot.
Can you do a fraction one?
No, because we are not going to have any homework for today, and we'll cover that tomorrow. Okay? All right, folks, no homework for the evening. Have a, oh, did you actually do it? That's what I meant.
Don't forget to like and subscribe.